15 contestants participated in a beauty contest. Each contestant was judged on 4 parameters: beautiful, B, rich, R, intelligent, I, confident, C. Each contestant has at least one of the 4 parameters. So we have 15 contestants. So the maximum value of any of these B, R, I or C could be 15. It can't be more than that. Also, it was found that twice the number of contestants who were beautiful was greater than or equal to the number of contestants who were rich, which in turn was greater than or equal to thrice the number of contestants who were intelligent. So this is one statement, one condition. Also, 4 times the number of contestants who were intelligent was greater than or equal to twice the number of contestants who were something, right? So this is the second condition. At the first go, when you read this, it looks like it's a question based on Venn diagram maybe. But we do not have enough information about the different regions of the Venn diagram, how they are related. So it looks to be a Venn diagram question. It is somehow related to logical connectives, but it's not a Venn diagram question. So we will have to form cases depending upon the conditions given. Let's look at the questions and further decide what level of difficulty this set is. So question number 16 uses the word maximum and it's a theta 1. Question number 17 is something definite. Question number 18 is something definite because it says it's never true, which means definitely false. Question number 19 starts with if and the word is minimum with a theta. Question number 20 is maximum with a theta, which means we're going to have a lot of cases where we need to find out the minima and the maxima. So most probably out of these 5 questions, only 2 are going to be doable, while the remaining 3 are going to be difficult one. So this set is not definitely easy. It's at least moderate or difficult. So how are we going to figure out the total cases and how we are going to arrange them? So let's look at the conditions given to us. So the condition is given that twice the number of contestants who were beautiful, so let's call beautiful as B, was greater than or equal to the number of contestants who were rich. For rich we are taking R, which in turn was greater than or equal to thrice the number of contestants that were intelligent. So this is the condition from the first statement. On the second statement, the condition is 4 times the number of contestants who were intelligent were greater than or equal to twice the number of contestants who were confident. Let's use C for confident. And this number was greater than or equal to the number of contestants who were rich. So for rich, we have taken R. Okay. So we have 2 inequalities, and if we pay a little attention, we will realize that R and I, it exists in both. And we have a common R here. So if we include both of these, can we say that 4I is greater than equal to R and that R is greater than equal to 3I? So this is the combined inequality that we can have, ignoring B and C as of now. Okay, let's call this first inequality and let's call this second inequality. And this is our combined inequality. Also, we will remember that the value of neither of these B, I, R and C is going to be more than 15 because maximum number of contestants we have is 15. Now, if I am going to put the value of I as 1, we will have 3 here, we will have 4 here, and R should be, between 3 and 4. So R could be 3 or 4. Similarly, if I put I as 2, so I will be having 3 into 2, 6 here, and 4 into 2, 8. So we are supposed to put in the values from 6 to 8. So it could be 6, 7 or 8. Now, as we put the values of I, we get the values of R, and with the values of I and R, we will be able to get the value of B, which stands for beauty, and the value of C, which is for confident. So let's draw a table with a lot of rows, okay? Because we don't know how many cases we are going to have. So the first column is case, the next one is intelligent, that is I, rich is R, confident is C, beautiful or beauty is B. So let's put the value of I as 1. If I put the value of I as 1, R goes from 3 to 4. So R could be 3, right? And if R is 3 and I is 4, sorry, I is 1. So this is 4 and this is 3. So the only possible value of C such that it is greater than equal to 3 and less than equal to 4 is going to take 2. And when I is 1, this is 3, R is 3. So B is going to be at least 2 so that it becomes 4, 5, 6 and so on, right? But the sum is supposed to be 15. So far we have 1 plus 3 plus 2, this is 6. So B can be 2, but then we will not have total number of people as 15. So in order to make the total number of people as 15, the minimum value of B that we can have is 9, 10 and it can go up to 15. Because all the 15 contestants may be beautiful. Okay. The next possibility is when I is 1 and R is going to be taken as 4, C will still be 2. This is so far 1 plus 4 plus 2 which is 7. Since this is 7 and we need the sum as 15, so the value of B is going to be at least 8. So it could be 8, 9 and so on, maximum up to 15. We cannot have any more possibilities with I being 1. Let's move to I being 2 now. When I is going to be 2, this becomes 6, this becomes 8. So the value of R could be 6. If the value of R is 6 and the value of I is 2, so the value of C is going to be between 6 and 8. So this is going to be 6. Now 2 plus 6 plus I is going to be 2. So this is 6 and this is 8. So we need a value between 6 and 8. So we can take that as 6. Okay. If R is going to be 6 and I is, this is 8. So 2C is going to be 6 or more. That means C is going to be 3 and not 6. 2C is 6. That means C is going to be 3. If C is going to be 3, the sum so far is 2 plus 6 plus 3, which is 11. So the value of B is going to be 4, 5 and so on up to 15. The next case is when I stays at 2, that is 6. And R takes the next value, which is, okay, let's keep this as 6. Let's say this is 8. If this is 8, C can take 4 also. So keeping R and I fixed, C changes. 2 plus 6 plus 4 is 12. So we can have 3 onwards up to 15. Okay. The next is what, we can't increase C further, right? So this is gone. Next is when R is going to be 7. So when R takes 7, that means this R takes 7. And remember, I is 2, so 4i will remain 8 so far. So the minimum value of C that we can take is 4, so that 8 is greater than equal to 7 and so on. So C is going to be 4. 2 plus 7 plus 4 is 13. So this is going to be, hold on, 7 plus 4 plus 2, that is 6 plus 7, 13. So it's going to be 2, 3 and so on up to 15. Okay. We can have more than 2 also possible. Can we have B as 2 when R is 7? No. B is supposed to be at least 4, right? So we can't have B as 2. So it should start with 4. So we have to look at all the 3 inequalities patiently, right? It's not an easy task. Okay, once we are done with this, I is still 2 and R is 7. We have taken R as 7. Let's take R as 8 now. If I take R as 8, so this is perfectly fine. So if we take R as 8, so we need a value 2C which should be 8. That will result in C being 4. Now since R is 8, B is going to be at least 4 again. So it should start from 4 and it should go up to 15. So this is the value that for B we will get. So in the case of 2, we get 4 such scenarios. So let's call them case 1, case 2, case 3, case 4, case 5, case 6. Let's look at 7th possibility. Let's change I to 3 now. Okay. If I is going to be 3, this changes to 9, this changes to 12, this is 12, this is 9. Now R is going to be at least 9 and beyond. So R is going to be 9. So this is the minimum value of R that we are supposed to take. The moment we get R as 9, so we will put 9 wherever it is suited. So I being 3, R being 9. Now the value of 2C should be greater than or equal to 9. That means it should be 10. So C is going to be 5. Now we need 2B to be greater than or equal to 9. So 2B is also going to be 10. That will give us the minimum value of B to be 5 and it can go up to maximum 15. Right? Okay. The next possibility is when I still being 3. Now what if we change the value of C to be 12? For 2C to be 12, C is going to be 6 because it falls within the range of 9 and 12. Right? So there is no change in the first inequality. That means B is still going to be from 5 onwards up to 15. So these are the cases when intelligent is 3 and R, that is rich, is 9 and C, that is confident, is going to be 2 cases, 5 and 6, and beauty is going to be from 5 onwards up to 15. The next one is, what if I change R to be more than 9? What if I take R as 10? So if we take R as 10, so we need 2C greater than or equal to 10. That will result in C being 5 and R is going to be 10. So 2B is 10. So B starts with 5. This is also possible. So R being 10, C is going to be 5 and B is going to be 5 onwards. So 5 to 15. I still being 3, R being 10, 2C being 12. So this can be 6. So 6 again. And B can still be from 5 up to 15. Very much possible. So we are done with the cases where R changes from 3 to 10. Now, next is when R becomes 11. So when R turns 11, so we need 2C should be greater than or equal to 11 but less than or equal to 12. So now 2C can only be 12. That means C should be 6. So I being 3, R being 11, C being 6. There is only that possibility. And 2B should be greater than or equal to 11. That means it should be at least 12. That gives us the minimum value of B being 6 and it can go up to 15. So there is only one case when R is 11. Now let's change R to be 12. Now when I is still 3, R is going to be 12. So 2C is going to be 12. That means C is going to be 6. And R being 12, B is going to be 6 and above. So 6 up to 15. So in the case of 12 also, we get only one scenario. So this is case number 8, 9, 10, 11, 12. We have found 12 cases right now. There are going to be more. Next, I is going to be 4. Let's see. So the maximum value of I we can have is 5, isn't it? Because we can't have more than 15. that we will see. So when I is going to be 4, this turns out to be 12, this turns out to be 16. So this is going to be 16 and this is going to be 12. Let's take the value of R to be minimum, which is 12. So I is going to be 4, R is going to be 12. If R is going to be 12, 2C is going to be 12. For 2C to be 12, C is going to be 6. And since R is 12, B is going to be 6 and above. So 6 to 15. Next is if 2C is going to be 14, then this is C is going to be 7. So the next is when C is 7. Now B will continue to be from 6 to 15. That doesn't change a damn thing about B. Next it is 16 when 2C is 16, which is within the range. C is going to be 8. So the next scenario is 4, 12 and 8. B continues to be from 6 to 15. Okay, the next value of R we can have is 13. So let's change that. So R is going to be 13. That means we can't take this 12. So if R is going to be 13, I is 4, R is 13. So 2C is going to be 14 or 16. Accordingly, C is going to be 7 or 8. And 2B is going to be more than 13. So 14 is what we need from here. That will make B to change from 7 onwards and not 6. So minimum 7 is what it will take. So this is 413. Next, what if we make R move to 14? So when R becomes 14, all the cases, they still make sense as the previous one, right? So this is 14. So this could be, C could be 7 or 8. And accordingly, this is going to be from 7 onwards up to 15 and then 7 onwards up to 15. So this is 4 and 14. This will make sense. Next is, what if R is going to be 15? If R is going to be 15, okay, should have changed this as well simultaneously. So the minimum value that 2C can take is going to be 16. And we will have I is equal to 4, R being 15. And that gives us C being 8, only one possibility. And since R being 15, 2B should be 16 at least. So B is going to be 8 and above. Now we can't move the value of R to be more than 15. Why? Because the number of contestants who are rich can be at most 15. So beyond 15, we can't take R. So that's the limit. So we have case number 13, 14, 15, 16, 17, 18, 19 and 20. So if we pay attention, these two are for case 1. The next 4 are for case 2. The next 6 are for case 3. The next 8 are for case 4. Okay. Next, when I is going to be 5. Okay. So when I is going to be 5, this turns out to be 15, this turns out to be 20, R will be 15 and 15 only, we can't have more than 15. So R is going to be 15, this is going to be 20, R is going to be 15, this is going to be 15. So when I is 5 and R is 15, now we need 2C greater than 15. So it could be 16, it could be 18, it could be 20. 2C is 16, that means C could be 8. 2C is 18, it could be 9. 2C is 20, it could be 10. And 2B should be greater than or equal to 15. That means 2B should be 16 and above. That gives us B should be 8 and above. So 8 to 15 is what we will have. So we were able to complete the entire table with a total of 23 cases. We can't have more than this. So as already assumed that this is going to be very time consuming set because we'll have to make all the cases. Now let's move over to the questions. Question number 16. What can be the maximum possible difference between the number of contestants who were rich and the number of contestants who were confident if there were 3 intelligent contestants? So if you're talking about 3 intelligent contestants, so we will have to look into the scenario where we had 3 intelligent contestants. And from here, we need to find out the maximum possible difference between the contestants who are rich and the contestants who are confident. So rich and confident, we need to find the maximum difference. So the difference between 9 and 5 is 4, 9 and 6 is 3, 10 and 5 is 5, 10 and 6 is 4, 11 and 6 is 5, 12 and 6 is 6. So the maximum difference is 6. So we are supposed to type in 6 because this is a theta question. So the answer is going to be 6. Question number 17. Which of the following cannot be the number of candidates who were both beautiful and rich? Since we are talking about both beautiful and rich, we are looking at R and B, the last column and the third last column. Let's look at the options. Can we have 4 candidates who are both beautiful and rich? So if we take the least number of candidates who are beautiful, which is 9, and the number of candidates who are intelligent, rich and confident, and if we add them, this will give us a total of 15. Since this gives us total of 15, that means the rich candidates are not beautiful and the beautiful candidates are not rich. Similarly, if we look at this scenario where we have 4, as in the next case, 1 plus 4 is 5, 5 plus 2 is 7, 7 plus 8 is 15. So that means these 4 candidates who are rich are not beautiful. Or there are 4 candidates who are beautiful out of those 8 who cannot be rich because the sum is 15. So 4, the very first option, is not possible. And in the case further, we do not see any more 4 rich contestants. There are more than 4. So we can say that 4 can not be that particular number of candidates who are both. Option A. Which of the following is never true? All 15 contestants are beautiful. We can have all 15 contestants beautiful. This can be true. All 15 contestants are rich. We can have all 15 contestants rich. This can be true. All 15 contestants are confident. We can never have all 15 of them confident. The maximum number of confident contestants we have is 10. So C is definitely going to be false. It can never be true. So answer is going to be option C. If every contestant has just one of the 4 properties, then minimum how many of them were beautiful? So since it says if they have just one of the 4 properties, so we are looking at the scenarios where the sum of all of them is going to be 15. So this is the first case. Then in the second case, this is going to be 15. Then in the next case, we are going to have 2 plus 6, that is 8, 8 plus 3, which is going to be 11, 11 plus 4, this is going to be 15. So if we look at the beauty wala part, 3 is the minimum that we see so far. So let's see if we add 2 plus 6, 8, 8 plus 4, 12, 12 plus 3, 15. Yes. So we can say that minimum 3 candidates can be beautiful. Since it's a theta question, we were supposed to type it 3. What can be the maximum number of contestants who were confident? The maximum number of contestants who are going to be confident is going to be 10, which we can very clearly see from the table. So since it was a theta question, we were supposed to type in 10.